Hello, good morning, good morning, good morning. Here we go. We're going to be talking about surds today. Surds act in the same way as normal multiplications, and we'll just show you how. Dive straight in now. If I've got root 3 times by root 5, what that means is we just do the 3 times 5, and that gives us a root 15. So it's as simple as that. Do another one as an example. If I've got the square root of 15 times the square root of 2, I'm just going to times the 15 and the 2 together to give us the square root of 30. So that's the basic introduction. On we go now to a few other types of cases. If I've got the same surd here, let's have a look what happens here. If I've got root 3 times root 3, I've got root 9, because 3 3s are 9, and the square root of 9, as we all know, is in fact 3. So what that means is that number in the surd, if you've got the same one, you're timesing it together, all you can do is actually remove the root sign. So there's a little test for you there. So we can do that in the same way as 8. We don't have to work out root 64 and then go down to 8. We could just write that as 8 because it's the same two numbers. Sometimes though, they're actually hidden. If I've got root 12 times root 3, even though they're different numbers, they do give us root 36. Don't leave it at that. If you can actually square root it to a whole number, it does go down to 6. Okay, those are those. Now if we move on to where we've got whole numbers and surds, so mixtures of those, we treat them separately. So I've done the whole numbers in brown there. So we do the 4 times 3. 4 times 3 gives us 12. And then we're going to have 5 root 2. That's going to give us root 10. So 4 root 5 times 3 root 2, we label the whole numbers at the beginning separately, do those in brown, and then the surds separately too. Looking at this example there, we're going to have 5 root 2, 5 times 2, gives us 10. And we're going to times that by root 3 root 12, which is root 36. That in fact is actually going to give us 10 times 6 equals 60. So again, as we've got a number which can be square rooted on there, don't leave it as a root, neaten it up, and you can get a whole number there. So always look out for that little trap where possible. Okay, going to be very athletic now and walk over to this board here. Okay, this one is called simplifying surds, and we can write surds in a more conventional way as you'll progress on as we go through the topic. If I've got root 8, the highest square root which gives a whole number is 4. So I look for that. That becomes 4 root, or root 4 root 2. And we can actually take that down to call it 2 root 2. So the technique here is make sure that we're looking for the highest possible number that we can square root. Sometimes it might be a bit more complex. We might have 147. Now 147 goes into 49 there, so we can make that 49. It's not root 2, it's actually going to be root 3, because 3 49s make 147. So 49 we can square root, that's the highest possible number we can square root, so that becomes a 7 there, and then we can square root and retain the root 3, so that becomes 7 root 3. Again, they might be hidden. If we did root 6 times root 10, that would give us root 60 using the rule over there that we've just started with. That can actually go down now to root 4, that's our square root number, and timesing it by root 15 to give us 2 root 15. And put the equal signs in there for mathematical neatness. So again, look out if they're hidden. Finally, we're going to go over to this board here to show you how surds can behave a bit like algebra. If you've got 3x plus x, you tell me straight away that the answer was in fact 4x. Because what we do, if we've got the x here and we haven't got a number there, it's an imaginary 1. So it's like 3x plus 1x gives us 4x. It works exactly the same with surds. We've got 3 root 7 plus root 7, that's like 1 root 7. The answer will be 4 root 7. In the same way, 3 root 7 plus 2 root 7 then gives us 5 root 7. Now, exactly the same with algebra, if we've got two different letters, say if we've got 5x plus 7y, the answer will actually remain the same because there are two different letters. You can't do anything to them, so that just remains the same. You cannot go any further with that. So it's the same rule applies exactly with a surd. If you've got two different surds, can you see you've got a root 2 there and a root 3? You can't do that to it. So in other words, the answer just remains the same as it is, and you cannot mix it. So there you have it. Here's an introduction then to some of the initial rules we'll come across when dealing with surds.